All right, so if we take a look together at Chapter 3 in your textbook, we're talking about factors and products. Okay, and you've heard these words before. Product, you know, is the result of multiplication. So if we multiply two things together, we get a product. Factors are the two things that you would multiply together to get a product. Now you can have uh, multiple factors, 3, 4, 5, 10 factors of a product. But let's say, for example, we multiply 3 times 4, and that will give us 12. So 12 is the product, and 3 and 4 are the factors. Get it? So the things that you multiply together are the factors, and the result is the product. These are some of the things we're going to be doing in Chapter 3. Okay, determining factors and multiples of whole numbers, prime and composite numbers, square roots. Okay, I won't go through all this because maybe all this doesn't make sense to you just yet. But this is what we're going to learn about. These are some new terms that we're going to use and learn about. So you may have heard of these before, and maybe some of them are brand new to you. Okay? So anyway, so this picture, which is split into 2 pages on my computer, but it's all one big page on yours. It's an aerial photo of a section of Manitoba, and the Dominion Land Survey divides much of Western Canada into 1 mile square sections. So this photo shows canola fields around Shoal Lake in western Manitoba. So if you grew up on a farm, or if you know anything about farming, I grew up on a farm. Farmed for 20 years with my family before I got into teaching. But the yellow fields here are canola, and some of you may know that. There are other fields that are blue. I don't know if you see them in this picture, but in the fall, fields that turn blue. Anyone know what field that is? What crop that is? Any farm kids? Flax. Yeah, did you say flax? Yes, it's flax. Very good. And so we can tell the difference between some of the crops. So that's good for you guys. All right. So 3.1 talks about factors and multiples of whole numbers. So in your notebook there, 3.1, okay, is factors and multiples of whole numbers. All right, so we talked about a little bit about factors and products here. So again, here's the example that I gave before. 3 times 4 is 12. The 3 and the 4 are factors. So those are the numbers that are multiplied together. This over here, the result of multiplying the factors is the product. Okay? Now, if we have 12 as a product, let's just go over here, are there any other numbers that we could multiply together to give us 12? So my question is, are there other factors other than 3 and 4 for 12? Very good. 6 times 2 is 12. Awesome. Okay, can anyone think of any more factors for 12? 1 times 12. Very good. Okay. Any others that you can think of? Not whole numbers anyways, right? Not whole number factors. So the factors for 12, factors for the number 12 are 1, 2, 3, 4, 6, and 12. Those are the factors listed in ascending order. Now here's a neat thing. 1 times 12 is 12. 2 times 6 is 6. And 2 times 6 is 12. 3 times 4 is 12. So the factors, when you list them in order like that, from smallest to largest, you kind of get this rainbow thing happening, and those are the multipliers. Okay. What about, let's see, what about 30? Can we list, I'm wondering if anyone can list for me some of the factors for 30. And let's see if we can do this in order. Now 1 is a factor for every number, right? What's the number the factor that partners with number 1? 30, okay? So you might want to do this. You want to go 1 on the far left, 30 on the far right. Just leave some space for other factors. Okay. All right, now what you do is you start moving up with the numbers, and you ask yourself, is 2 a factor of 30? So is there a multiplication expression that would involve 2? Something times 2? Yeah. So 2 you would list. And what is it that we multiply by 2? 15. Awesome. Very good. Now, the next number up from 2 is 3. Is 3 a factor of 30? Yes, it is. Why? Because 3 times 10 is 30. Okay, what about 4? 4 times another whole number to give you 30? I don't think so. What about 5? Yes. 5 times 6, right? Now, when you get to this point, there are no other numbers between 5 and 6, so guess what? Your list is done. Alright? So 1, 2, 3, 5, 6, 10, 15, and 30. Just to double check that, 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, 5 times 6 is 30. Okay? Is that good? Okay. I'm going to go back for just 1 second here. I'm going to go back and I want to ask you if... Oh, why is this not working here? What I want to ask you is, if I go back to that 12, can you think of any numbers that would fit in here if I multiply 3 things together? Would I be able to have 3 factors for 12? Is there any numbers that we can put in here, again, whole numbers, that we can put in here that would finish this statement off? Anybody have any ideas? Whoops. 1, 3, and 4. Okay, well, 1, 3, and 4. Okay, that's good, yes. I mean, honestly, we could have any number of boxes if we just keep adding 1, right? So, yes, that is totally true. Are there any numbers other than 1 that we might be able to put in those boxes? Yes? 2, 3, and 3. Close. You're close. You're close. Yes. I think you realize your mistake there as soon as you said it. Now 2 times 3 times 3 would be 2 times 3 is 6 times 3 is 18. So what you meant was maybe another 2 there? Is that what you meant? Okay. So let's see. 2 times 3 is 6 times 2 is 12. So yes, that works. And actually, do you know what these 3 numbers have in common? I know 2 and 2, they're the same, but what could you call those numbers? Anyone know? What are those numbers? Those are... Yes, someone said it. Prime. Yes. Those are prime factors. Very good. Prime factors. Now, prime factors you're going to find, and maybe you've had some experience with this in grade 9, okay, you're coming from grade 9 math, but prime factors are really important in determining lots of things that we're going to need to work through here in this section. So, prime factors. The process of determining what the prime factors are for a number is called prime factorization. Prime factorization determines prime factors for a number. And there's different ways of doing this. I'm going to show you my favorite way first. It's really quick, it's really easy, and you can basically very easily and quickly figure out the prime factors for any number, large or small. This is my favorite way. It's called the ladder method. So if we did 12, let's start with 12. We know what those are, and I'm going to show you how easy this method is. So you start with 12. What you do is you put a little kind of an L shape right here underneath the 12, okay? And just to separate this 12 from the numbers that you're going to put around it. And what you do is this. You take this number and you divide it by either 2 or 3. Sometimes you have to go to 5, but we're talking about prime numbers. Now, what are the prime numbers? Let's just list some of them. The prime numbers. 1 is a prime number. We're not going to talk about 1, because dividing by 1 does not help us, does it? But 2, 3, 5, what are some more? 7's the next one. Sorry? 11 is the next one, and yeah, 13, okay, and there of course are more, but those are the ones, let's focus on those, that's all the ones you're going to need to know for right now. So, if I divide 12 by, and let's go with the smallest one, 2. Put the 2 there, and you put the quotient, which is the result when you divide, you put it underneath the number. So 12 divided by 2 is 6. So you would put 6 there. Okay, everybody got that so far? You put the prime numbers here on the side, and then the result down here. Now, you do the ladder again. It's called the ladder method, I think is what Mrs. Bryce calls it. For some of you that maybe have seen this before, but you put another little L shape under there, and 6 divided by, can you divide 6 by one of these prime numbers? Yep. Go 2 again. What are you left with? 3. Now, when you get a prime number in the bottom like this, then you know you can stop. And you look at these numbers on the side, and the one on the bottom, and those are your prime factors for 12. That make sense? Okay? So we could do the same thing for like, I don't know, let's do 85. Let's do a big number, okay? Let's do prime factorization for 85. Well, 85 is an odd number, so can we divide it evenly by 2? No, can't divide evenly by 2, so you would skip 2 and you would go to, well, you could go 3 or you could go 5 or 7. Which is the one that maybe is the easiest to figure out? Okay, 5. You know that it's divisible by 5, right? So what's 85 divided by 5? Well, for those of you that don't reach for your calculator just yet, think about this. You know what 50 is, right? That's 5 times 10, right? And then 50 plus 35 gives you 85. So this is 5 times what? 7. So if you do 85 divided by 5, how many groups of 5 are there in total? Sorry? 17. You got 10. You got 7 here. So you can do this on your calculator. That's not a sin or anything. But if you're thinking about this mentally, and you should try to do as much mental math as possible. You should exercise your brain that way. Group it into 50 and 35. 50 is 10, 35 is 7. So you've got divided by 5, and you get 7. Oh, what do you notice about this now? That's a prime number, so guess what? You can stop. Oh, 17. Okay, thank you. 17. I missed the one there. But is 17 a prime number as well? Yeah, it is. So 17. Sorry, 7. I was thinking about this one here. So 5 and 17 are your prime factors for 85. Okay? Okay, what about 330? Let's keep going and go faster here. Okay, so 330. I can divide that by 3, I think. Can you? Or 5. Which one would be easier? Oh, 2. Yes, 2. Why? Because it's even. So as soon as it's even, divide by 2, because that'll bump it down, to a reasonable number. So let's do 2. What's 330 divided by 2? That's 165. Is it? 165. Okay. Now, can I divide this by 2? Nope. 3? Maybe. 5 for sure. So let's do 5. And you don't always have to do the smallest one, but, you don't have to do the smallest one. So what's 165 divided by 5? Well, it's a little bit tougher. We've got 5. Yeah, we've got 5 times 30 is 150, right? And then you've got another 15, don't you? Right? So guess what? We've got 30 and 3. So would that be 33? Yeah. All right. Is 33 prime? Or can we divide 33 by something? Yep. Divide by 3 to get 11. 11 prime. So here are your prime factors. So 330 is 2 times 5 times 3 times 11. Prime factors. Okay? Now you can do that method with any number. The other method I'll show you real quickly that you might like as well is, well, let's take a look at 330 again, and let's say, okay, let's do the, I don't know what they call it, the tree method or something? Factor tree method, I think, okay? So 330, you could split that up, and you've got 2 and 165, right, like that. And then 165 you can split up, right, into, what is it? Did we say 5 and 33? And then 33 can be split up into 3 and 11. So this is the factor tree method. And when you get down to the last factor being prime, there you go. There's your list. Same thing. So you might like that method too. I think the latter one is a little bit quicker. Okay. Why is this a big deal? Well, we can compare factors for two different numbers. And one of the things that we want to do is to find the GCF. Does anyone know what that stands for? The greatest common factor, yes. So the greatest common factor between 2 or 3 or 4 numbers is something that you're going to want to be able to find pretty easily. So here's the question. So in this example, we'll say, what is the greatest common factor of 28 and 42, or between 28 and 42? So what factors do they have in common? Well, let's do this. Yeah, you might be able to tell right away with these numbers, but what you can do is you can prime factor each of these, or you can write a list of factors like we did first. So let me do it both ways. Okay? First of all, let's do 28 and 42. Let's list the factors of 28. And they are 1 and 28, 2 and 14. Can we divide 28 by 3? No. By 4? Yep. 4 and 7. And 5 or 6? No. So here's our list of factors. Now this is not prime factors, right? Not prime factors, but they are factors. So 42, 1 and 42, 2 and 21. Can we divide this by 3? Yeah, you should be able to. What's 42 divided by 3? 3 times 14. What about 4? 5, 6? 6 and 7. Okay? So there's your factors for 42. And to find the greatest common factor, you would simply look at the list and you'd say, okay, which factors do I have in common? 2, 7, 14, and you'd say which is the largest, the greatest of those. So 14 is the greatest common factor. Okay, see that? Greatest common factor. Knowing the greatest common factor is going to be very important for you guys. Let's do it one more way. Let's do it the prime factorization method way. Okay. So here's method 2. Okay, prime factors. Look at the prime factors. So let's do that. So 28 over here, 42 over here. So 28 divided by 2 is 14. Divided by 2 is 7. 42 divided by 2, 21. Divided by 3 is 7. So the prime factors are 2 times 2 times 7. And over here, it's 2 times 3 times 7. Everyone see that? Now, if you're doing the prime factorization method, which, to tell you the truth, that went quite a bit quicker, didn't it, than punching in your calculator, like 42 divided by 3 is what, and, right? This actually is quite a bit quicker. And so what you do is you say, hey, these are the prime factors. How many do I have in common? What's in common? Well, a 2 is in common. See that? And this 7 is also in common. So what's 2 times 7? That's 14, right? So 2 times 7. So 14 is a factor of both of them, and that's how you figure out the greatest common factor using that method. You identify which ones are common to both lists, and then you just multiply them together, and that is your greatest common factor. So 14 is GCF, method 2. Just another thing I'll show you here, when you're listing your prime factors, you may see this in the textbook. For 28, you may see this. Because there's two 2's here, sometimes they write it as 2 squared. So that means 2 times 2 times 7. Okay, so you might see that in the textbook as well. Alright, so let's just step it up a little bit. Let's add 3 numbers. Okay, let's see, I'll try and pick a question from your assignment. Okay, so why don't you, let's do this together. If you want to jump ahead of me, you can, but for those of you that are still struggling to know what to do here, let's find the greatest common factor for these 3 numbers. I'm going to do the ladder method, so let's do this together. 120, let's break it down to prime factors. So divide that by 2, what do you get? 60. Let's divide that by another prime number, let's say 2, 30. Divide that by 2 again, 15. See, if you can divide by 2, those are really easy, so keep going as long as you can. 15 can be divided by 3, and you get 5. So that list is now complete. 960, and we'll do the other 2 real quick. Notice from 60 down, you don't have to do it the same way every time. You see, from 60 down here, I went 2 different kind of routes. I still got the same numbers though, 2, 3, 2, 5, 2, 2, 3, 5. Still the same numbers. Okay, and then 1400. Let's do 1400. Cubed, 1, 2, 3, times 3 times 5. Okay, and here I have 2 to the power of 1, 2, 3, 4, 5, 6. I have 2 to the power of 6 times 3 times 5. And over here, 1, 2, 3, so that's 2 to the power of 3 times 5 squared times 7. Okay, does that look right to you guys? You guys get that as well, or is there, you good with that? Okay. Now the greatest common factor, a list that looks like this might be a little tricky to see, I'm not really sure, but what is common to all of these lists? Okay, we have a 5, yes, thank you. Okay, so you notice that we have a 5. Now is 1 5 common to both? To all 3? Yes, we have 1 5, even though this one has 2, the other ones don't. So we're going to go 5, yeah, that's common. What else is common? How many 2's are common in every list? 3. So 2 to the power of 3. That's common. Is 7 common to each list? No. Is 3 common to each list? 1 there, 1 there. Oh, but not over here. So do you see how that's working? So this is all that's common to all 3 lists. So what is that? 40? 5 times 8? 40? Is that right? Let's take a look. Here's another way of doing it. Okay, let's do red over here. So you have this is common. This 2 is common to all 3 lists. You have another 2 that's common to all 3 lists. You have another 2 that's common to all 3 lists. So if you do that, you can do that as well. So that's 2 times 2 times 2. And then you have a 5 that's common to all the lists. So whatever you've circled, then you just multiply it together in any of the lists. You see? 2 times 2 times 2 times 5 gives you 40. So that's how you can use prime factorization to find greatest common factor. Questions? I also want to teach you today about finding the least common multiple. Now, a multiple is basically a multiple of a number. Let's say multiples of 2. Well, that would be 2 times 1. Another multiple would be 2 times 2. Another multiple would be 2 times 3. And then times 4 and times 5 and so on. So you basically take the number and you times 1 to get that one. You times 2 to get the next one and so on. So if you had 11, the multiples of 11 would be 11 times 1, 11 times 2, 11 times 3, 11 times 4, and so on. Okay? Multiples. In math, it's going to be beneficial for us to be able to figure out what a common multiple would be. And there would be lots of common multiples, but the smallest common multiple is going to be helpful for us. So usually we do least common multiple between two or more numbers. So let's do an example. Okay, let's say 12 and 14. So what is the least common multiple? Abbreviated by LCM. Okay, now be careful. Be careful what you're thinking now. We're not talking about factors. We're not talking about factors. We're not talking about a common factor. We're talking about multiples. So remember, multiples have to be bigger than the number, not smaller. You cannot have a multiple that's smaller than 12. Okay, so again, we're not talking about factors. Instead, we're talking about multiples. So let's list some multiples of 12. This is pretty easy actually to do in your head, right? So 12 times 1 is 12. Now notice that these numbers are not getting smaller, they're always getting larger. 24, 12 times 3 is 36, 12 times 4 is 48. Okay, now we might have to write some more, but let's go to the other number and see if one of these match up here yet. 14 times 1 is 14. Times 2 is 28. Oh, we're close there. What's 14 times 3? 42. What's 14 times 4? 56. What's next? 70. What's next? Oh, we're not running into anything common here yet, are we? So we might have to keep going. Sorry, not 80. 84, yeah. And if you haven't noticed already, we're just adding 14 each time, right? So that might be helpful. Let's go back to our other list. What's 48 plus 12? Another 48 is going to be 60, and then 72, and then what? Oh! 84, look at this, we've got a winner. 84 appears on both lists. It's the first number to appear on both lists, right? So 84 is the smallest, or lowest, common, that's in both lists, multiple of the lists of multiples. So 84 is the LCM, lowest common multiple between those two numbers.